Problem is that methane is a much more potent greenhouse gas than carbon dioxide. I'll repeat that. One molecule of methane absorbs much more heat in the atmosphere than does a molecule of carbon dioxide. By how much? Well, it depends upon how long you're willing to measure. If you're willing to measure out 100 years and compare that, methane is 33 times more powerful than carbon dioxide. So one methane molecule has the heating potential of 3 molecules of carbon dioxide. If you only want to measure over 20 years, and remember, we only have 30 years to fix this climate problem, then it's a factor of 105. One methane molecule has the same heating potential in the atmosphere as 105 carbon dioxide molecules. Conclusion, a very small amount of methane is as important as a large amount of carbon dioxide. So what? Methane leaks during gas development, purposefully and accidentally. I showed you different forms of leaking, didn't I? I'll show you some more in a minute. So during the process of developing natural gas, either conventionally or unconventionally, there is methane leaking, either purposefully or accidentally. It's important to know how much. In research that we're doing at Cornell, we're trying to quantify it. So now I'm going to show you what most people in industry and what my colleague Don Siegel says never happens. During flowback, right, millions of gallons of flowback fluid for about 2 weeks has a lot of gas in it. Where's that gas go? Well, they can't hook it up to a pipeline because then they'd be putting frac fluid in the pipeline. They could possibly separate the gas from the liquid. They could, and then they could either capture it or they can burn it in a FLIR. But according to the EPA, 85% of the time, it just gets vented. You've seen the same movies I've seen on YouTube. Somebody goes to a frac site and they're taking a video of the flowback process, and you're seeing a big slug of fluid and then spurting. Pss, 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 pss. That's the gas coming out. I'll show you a video. This is a still photograph taken by a friend of mine in Pennsylvania in Dimock during the flowback period of a couple of wells in Dimock. Here you see water vapor. You can see water vapor with the naked eye. For scale, here's a piece of heavy equipment. Now I'm going to show you a video that was taken with a special camera called a FLIR camera, forward-looking infrared radar, which can be tuned so that what it sees is what the human eye cannot see. It can see heat, for example. If it's tuned to see heat, it can see hydrocarbons. Ooh, you can't see methane. It's colorless. But you can see it with a FLIR camera. And so you're going to see a video. And I'll explain what you're looking at here. Everything which is yellow is a hydrocarbon. Okay? Everything which is yellow is hydrocarbon. Notice that it's rising because methane is lighter than air. It's 58% of the density of air. Methane comes out of the ground, up it goes. It's also hot because it's about 200 degrees Fahrenheit down there, so when it comes up, it's hot. So up it goes. Is that just a little leak? Watch, we're going to pan over here now, and you're going to see that same piece of heavy equipment come into the scene. There it is. So what you're looking at here is not a little pinhole leak. That's billowing clouds of methane, which companies say doesn't happen. But EPA says it happens 85% of the time, and there's a video that says it happened